Welcome, Mr. Krishna Moorthy, to this podcast, Semiconductor Advancements in India. I am Dr. Sriganesh Rao, member of a research team under Maitri Grant program of DFAT Australia for developing a roadmap for Australia-India strategic collaboration on semiconductors. Mr. Krishnamurthy, you have been a veteran in the electronics and semiconductor domain with more than 4 decades of global experience. You have held several senior positions in this domain. You have been instrumental in developing a strong semiconductor ecosystem in India through association with the India Electronics and Semiconductor Association, being its former chairman as well as the CEO and president. Subsequently, I recall that your semiconductor design journey started way back in 1987 when you designed the first ASIC in India for use in strategic electronics application by collaborating with a UK-based company. Welcome.
Thank you, Sriganesh, for having me on this podcast. Delighted to be talking to you.
Yeah, it's a great opportunity to have you on this podcast. At the beginning, actually, could you briefly tell us about your personal journey in the electronics and semiconductor domain for the benefits of all the listeners?
Okay, sure. So, both of us started our career with Bharat Electronics Limited in Bangalore. And that's where my foray into semiconductor started. I was part of the system design and engineering group in Bharat Electronics for defense communication systems. And while we were developing some of the advanced communication systems of those times, primarily for secure communications, the need for higher levels of integration started becoming very obvious to the design engineers. And that's when we started seriously contemplating how do we pack more electronics into a single chip. And that led to our design of the first application-specific integrated circuit ever designed in India in the 1986-87. The technology that was contemporary at that time, if you remember, Sriganesh, was 2-micron 3-metal CMOS. And we had the benefit of being, having a partnership with a British electronics company who also were into strategic electronics, as well as they had their own semiconductor business. So they were a willing partner, and using their fab facilities, we were able to design using their PDKs and then subsequently get the ASIC fabricated in that fab, which went into a lot of communication systems used by by India in the subsequent years, specifically for the strategic electronics. And we were able to understand and appreciate how important it is right from those days for the advancements that are required for you to be a significant player when it comes to semiconductor design and subsequently semiconductor manufacturing. So that was my initial forays. And then, of course, later in 99, 2000, I joined National Semiconductors, incorporated their India Design Center. National Semiconductor, as you know, was headquartered in Santa Clara, USA, and I was the director of engineering here. And I continued my semiconductor journey with them for almost a decade. And subsequently, when it got acquired by Texas Instruments, I was part of the Texas Instruments design team in Bangalore, in India. And subsequently, I became the managing director and corporate VP of Rambus Incorporated, another very high-end R&D company focused on advanced semiconductor IPs and products development. And there, again, I spent a decade, close to a decade. So altogether, I would say, though the first half of my career was in electronic systems, which was using semiconductor devices, the second half of my professional life was completely into semiconductor design, both in analog as well as digital and analog mixed signal in that order in National Semiconductor, Texas Instruments, and Rambus. So that's my brief semiconductor journey. And subsequent to that, in 2021, I assumed the position of the CEO and president of India Electronics and Semiconductor Association, which is a trade body representing all the major electronics and semiconductor companies in India. And even today, it continues to be so. And primary objective was to further the cause of semiconductors ecosystem, developing their semiconductor ecosystem in India. And it was that time, in December 2021, 15th of December 2021, if I remember the date correctly, that the India Semiconductor Mission was announced by Government of India. And I would say there was no looking back from that time onwards. Thank you.
Well, it's been a great journey of yours. Wonderful. See, nowadays we are hearing a lot of news about semiconductors in India in the last probably couple of years. So could you please explain us the significance of this?
The news that we keep hearing of late in semiconductors, all that started when the India Semiconductor Mission was announced. But the need for semiconductor advancement started way back. So if you remember, we had a very good semiconductor design and a reasonable technology manufacturing capability in Bharat Electronics. Subsequently, yes. Government of India set up the Semiconductor Complex, SCL, in Chandigarh. And then there were, of course, other pockets of I would say activity in semiconductor domain. Some of it was happening in Siri Pilani, where they were developing some very specific devices. And then there are a few companies who are trying to do some assembly of semiconductor devices in India, like Continental Devices, etc. And they are all there still. But they were all, I would say, a non-cohesive and islands of activity, if I can use that word, in the semiconductor ecosystem. But the advent of India Semiconductor Mission was primarily that it created a homogeneous platform for developing the entire ecosystem. So it's not that they just looked at semiconductor design, but they also started looking at the rest of the semiconductor ecosystem. So that's where you start hearing a lot of news of late. But the design per se started, I would say, way back in 1985 or 86, when Texas Instruments set up their design center in India, in Bangalore. I think it was 85 or somewhere around that time, 85 years. And then over the years, almost all the semiconductor majors in the world set up their captive design centers. And they were leveraging the immense talent that this country produced. And though initially it started with a certain amount of customized software for semiconductor design, subsequently they migrated to the chip design, particularly the verification, the backends activities, the place and route, etc. But subsequently, over, I would say, by end of last century and the beginning of this century, like 2000 onwards, almost all the major design houses had started developing products out of India completely. And by mid of 2020, I would say we had maybe 200 kind of design centers set up in the country, out of which at least 100 of them were developing end-to-end product development. So that was the platform that was set, or the ecosystem that was created, which worked very well. And then the pressure for availability of semiconductors manufactured out of India became acutely visible to everyone during the COVID time. And that's when the supply chain got completely disrupted, and the availability of semiconductors became a major bottleneck. Okay. And I keep giving this example. I was the CEO and president of IESA, and the first call that I got about the shortage of semiconducttors was not from Ministry of Electronics, but it was from the Ministry of Finance, Government of India. Right. And they said, what are you doing for getting removing the semiconductors supply chain bottleneck? And I was a little surprised, but they said, yeah, for every car or a truck that's standing there because they are not able to ship it because a semiconductor chip is not available, it's like crores of rupees of duties and taxes which the government will receive if those vehicles were to be on the road. So it was what I'm trying to emphasize here is the need for a complete supply chain of semiconductor became very evident during the COVID time.
Sure.
That's
So
why
in
we are
terms of a
building.
country's economy and
Yeah.
the national security,
Yes. Yeah,
you know, it actually plays a large role. Could you explain
absolutely.
what kind of role it plays, for a national security today and for the economy of the country?
Yes, as I said, the need was felt way back when we were all working for the defense electronics company, that we definitely need a good handle on semiconductors availability within the country, and that continues because now the kind of systems that India builds in strategic electronics is far more complex than what we built 2 or 3 decades ago, and it's all the more reason why India needs to have the complete semiconductor ecosystem available within the country from a national security point of view. And of course, the size of the consumption with all the modern electronic devices and the gadgets, the phones and the laptops and the home entertainment systems, the broadband connectivity devices. I mean, you name it. Practically, you wake up in the morning with electronics and you go to sleep with electronics in the night. There is no part of our life which is not touched by electronics, and every one of them consumes semiconductors. And our dependency on semiconductor consumption is somewhere in the range of 25 to 30 billion dollars today, and it's expected to touch 100 plus billion dollars in the next few years. And that's a huge kind of number. And not being able to, and all of them are not the top of the line, more complex or the most complex devices. A majority of this, I would say even 70% of them probably will be well within the grasp of Indian manufacturing capabilities, provided they are set up with the right ecosystem, with the right support from the government mechanisms. And I think that's what's happening today with the advent of ISM 1.0. I think the 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 whole the whole momentum is now going in the right direction. And as I said earlier, it was all there, but in pockets of activity not connected to each other, and each was being driven by a certain set of people who had deep interest. But today, it has become truly a national mission. And I keep talking about this example wherever I get an opportunity, that the space mission, the atomic mission, and the semiconductor mission, these are definitely and now of course, government has also started the energy mission. So
Energy.
I think we are building the country on some very strong foundations.
Yeah. Okay. For a country to enter newly into in this area, like, what do you feel is more appropriate for a country to adopt? The fabless design of the chips or the fabrication plants?
Well, I would answer the question a little differently. It is not a question of what's important.
Mhm.
Uh, uh, in some sequence, both
Or
are
appropriate?
yeah, both are equally
Yeah, what
important.
would be appropriate? Yeah.
Yeah, but then the right sequence is exactly what India did. They got into the design because that's where you require much lesser investments, number one. And number two, you also need to have a pipeline of products that goes into manufacturing. Now, the current situation in the world, particularly with the current geopolitical topics that you are all quite familiar with, it's not going to be very easy for a company to trust a foreign country for completely managing their manufacturing requirements, because the supply chain disruption and its aftermath we all have seen multiple times in the last 5 years, and I think the world has learned a lesson. So having a strong design ecosystem is very important for the manufacturing to follow and to sustain over a long period of time. Sustainability becomes very important, and hence the sequence that India did, I would believe that's the right thing to do. And that if you really study the global scenario, from 1959, 1960, when the semiconductor design started in US, the manufacturing at a larger scale happened much later. Somewhere in the 80s and 90s is when the semiconductor manufacturing assumed scale in USA, but the design was happening almost 15, 20 years before that. And I think that model has not changed anywhere else. Taiwan, of course, is an exception, but then there are different reasons for that.
So India has adopted the right model, had a very good experience in the fabless design since a few decades, and now entering into the fabs.
Absolutely. Absolutely, I agree.
Okay, you also mentioned about the India Semiconductor Mission, ISM. So could you tell us more about this mission and the incentives that they provide, which is, which will be helpful for the, for the ecosystem to develop here?
Yeah. Yeah. Oh, yes. The India Semiconductor Mission, as I said, was launched formally on December of 2021, and it was a path-breaking kind of announcement. I don't remember any other program of the government of India in the last several decades that we have been with the industry that came out with a absolutely laser-focused kind of approach to further the semiconductor manufacturing in India. So India Semiconductor Mission's 1.0's focus was totally on the manufacturing to enable semiconductor fabs and also the semiconductor assembly test and packaging capabilities. Because the ecosystem becomes complete when you design, then you manufacture the wafers, and then assemble, test, package. It goes into a warehouse from where it gets distributed to all the electronics products companies to use them. So the second and third pillars of that ecosystem was completely missing in the country, or it was fragmented. I would say very fragmented, very small in scale and size. And that's what India Semiconductor Mission decided to address. And they gave substantial incentive, I think up to 50% for silicon fabs and also for the compound semiconductor fabs subsequently through an amendment. And then later, and of course, they also included the ATMP OSATs also as part of the scheme. So we have seen in the last 4 years, how many? Maybe about 10 companies have established or are in the process of establishing manufacturing capabilities in the country, which is a big number to get in 4 years to get 10 semiconductor manufacturing and assembly test companies to set up operations and build the factories. And as you know, Sriganesh, you are deeply involved in the semiconductor domain yourself. Setting up a semiconductor fab or an ATMP or OSAT facility is quite time consuming, but more importantly, they are very, very capital intensive. So the whole ISM policy was tailored to mitigate the business risk of making those kind of investments, because we are talking about billions of dollars of investment. Right. A modern semiconductor fab, even in the planar technology, the non-FinFET planar technology, still needs maybe $8-10 billion of investment before you can go into large volume scale manufacturing. And I'm talking about volume scale manufacturing. We are talking about something like 30,000-40,000 wafers per month start. And its contemporary manufacturing capabilities are somewhere in that range, anywhere between 30 and 50,000 wafer starts per month. So to get to that scale, the capital investment required runs into billions of dollars. And that, facilitating that, mitigating the risk, and ensuring that the funds are not becoming, and also the ecosystem parameters that are required to support this kind of large, very deep tech manufacturing was all enabled by the India Semiconductor Mission. And I would say it was a path-breaking kind of initiative from the government at that time.
Yeah, that's excellent. Yeah, you actually mentioned about the fabrication, the incentives which were given for fabrication. How about on the design? Now, we have the design-linked incentives, and probably if you could explain how this DLI scheme has helped the Indian ecosystem.
Yeah. So as I said, the design ecosystem was growing. I would say 1990 onwards, primarily through the captive design centers of the global semiconductor companies, and they were quite successful, and every one of them expanded significantly, and most of them claim today that they're number one or number two design capability for the global semiconductor companies. Outside of US or even including US is the largest one in India. So they have grown to that size. But they are essentially leveraging our talent, making big investments in India for setting up huge design centers, bringing in the latest of design techniques and the contemporary IPs which the companies own, and they were converting that into real cutting-edge product out of India. But if you really want the Indian ecosystem of manufacturing and ATMP to succeed, it is very, very important that we also have India-designed products for India as well as for the global market. So that's what the second piece of the puzzle that was addressed by the government to supplement or augment the ISM approach was to announce incentive for design companies of Indian origin. So that's where the design linked incentive DLI came into force. And to the best of my knowledge, the last count, we have about 25 to 30 Indian semiconductor companies in different stages of evolution. Some of them have got their first products out, others are going to tape out very soon. And some of them have got the first tape out design in the lab, and they are testing and characterizing it. So it's in different levels of evolution, but we have to say that we have at least 20, 25, 30 Indian startups being looking at some of the modern semiconductor products, which can rub shoulders with global products of any companies. I think that's the big outcome of the DLI scheme. And I gather that the DLI 2.0 is also going to come out in the next couple of months. And the industry is eagerly waiting for that. And I think, at least I know that there are a dozen companies who are waiting for DLI 2.0 to come. So that shows the success of DLI 1.0, and its beneficiaries have really taken off. And the design ecosystem has started believing that the DLI is going to make them successful. So that's the good part of the DLI scheme.
Well, it's excellent. So what is the role of IESA, like, in advancing this ecosystem through policies and all that? Like, IESA works with the government to define policies?
Yes, IESA was established as an industry body, I think, in 2005. So IESA is in existence for the last 21 years. And I think the Vision Summit is happening this month, 24 and 25 of February in Bangalore. So the role of IESA is primarily to work with multiple stakeholders. Primarily, number one is government, and IESA played a significant role in giving strategic inputs and tactical inputs for formulating ISM policy in the first place, and subsequently worked very closely to get the DLI formulated. And then the flagship event of the semiconductor industry called the Semicon, IESA is working with SEMI of USA to organize that event. And each one of them has its own telling impact on the growth of this ecosystem. Today, I would say even state governments work very closely in setting up centers of excellence in their respective states, trying to get their state level policies formulated, and also make sure that the states do not miss out in attracting investment on semiconductor ecosystem play. And again, it's not just the semiconductor design and manufacturing. The ecosystem also consists of a lot of other things, and you know it very well. The dependency on the chemicals, the gases, metals, and minerals that are required. A modern fab today consumes anywhere from 100 to 150 different components. Components meaning the chemicals and metals and minerals before a chip is made. It could be in very small, minuscule quantities, or it could be in large quantities, but all of them together play into the semiconductor manufacturing ecosystem. So that's what the 2.0, ISM 2.0 is expected to address with the announcement that they made recently. The second vector IESA works very closely is, of course, with the industry, because they are the beneficiaries of all these policies. So working with the industry, trying to understand what are the pain points and how to mitigate that. And the third, of course, is with the academia, because finally, you need to have the most important raw material for both the design and manufacturing is the trained manpower. So skilling and training is another area where IESA works very closely with the universities, etc. So they play 360 degrees in the semiconductor ecosystem, and that's precisely why IESA has been formed for that. And on the recent years, I would say 2021 onwards, IESA has really worked shoulder to shoulder with governments, both at the central level and the state level, in furthering the cause of semiconductor design and manufacturing ecosystem.
Yeah, probably you can also mention, I mean, we have the Semiconductor Fabulous Accelerator Lab, I think, which was an initiative of IESA.
Yes, that's correct. That's correct. That's in the Bangalore ecosystem. We have the what's called the SAFAL, Semiconductor Fabulous Accelerator Lab, and a similar initiative is now happening in 3 other states. And IESA is providing is a knowledge partner, but I think in 2026, similar initiatives will happen in 3 or 4 other states in India. So the overall ecosystem is now developing bottom up in the startup space, on the design side, as well as on the manufacturing side. Big companies and medium-sized companies have strong belief that investing in India with all the kind of government support, and some of the companies are bringing most advanced technologies. So that's very important. It's not that they are just bringing a proven and beaten kind of technology. Some of the companies are bringing gallium nitride kind of fab, glass substrate based packaging, which are totally state of the art. So that gives us the real happiness that the world believes in India, the world believes in Indian capability, and also the world believes in Indian talent. And the sustainability has been underscored by when people bring in this kind of cutting edge technology investment to the country.
Yeah, in the fabulous design area, right? We see a lot of MNC companies being and also domestic startups being headquartered in Bangalore. So, what do you think of Bangalore as the ecosystem for the semiconductor design area?
Well, historically, that's how it developed. Again, the reasons are not very difficult to find. Bangalore was the hub of deep technology with all the DRDO labs, the space department, and defense PSUs, and top-notch schools like the IISc. So the I would say that a dormant ecosystem was very much there, and the global companies came into India. They didn't have to look beyond Bangalore because they found that all the ingredients that are required for their success was available here. So that's how this whole thing started, as I said, way back in 1985. But then every company who came here oh, we want to start something to do verification or something to do chip layout. And then soon they realized that they can do much, much more than what they originally planned for. And today, some of the majors in the world, like the Intels and the AMDs and companies like that, they are talking about design centers with 5,000 people, 6,000 people, which is huge. And that all came together because the ecosystem was very supportive. Of course, the schools played a big role. As I said, the kind of talent the local ecosystem was able to provide, the leadership talent that was available, the managerial talent that was available, all of them played very well into the Bangalore semiconductor success story.
And how is the Indian approach for this in terms of the policies? How do they compare with the policies of, say, US, Taiwan, or South Korea, and these countries?
Oh, I would say the ISM 1.0 policy is really path-breaking. I don't think any other country in the world offered this level of policy support ever.
Okay.
But then I think having seen what India has done, some other countries have started, but I would say formulating their policies or redrafting their policies, modifying their policies to be competing with India's policy in semiconductor manufacturing. So I would say we are leading the pack, so to say, when it comes to the policy support. And the size is quite substantial, and the focus and the selection process, the rigors that each company goes through to qualify is amazing. So I would say a lot of people have put in their incredible amount of time and energy to make the policy so good. Now, if you look at countries like even US for that matter, or Japan and South Korea, etc., they all have made some tweaks or some changes, some adaptations in their policies to make it look better for the investors. It's not that they are not supporting it; they were already supporting. For example, Taiwan was always leading the semiconductor manufacturing as a world world leader destination for semiconductor manufacturing. But the others are now trying to get there sooner than later. And even many European countries are also trying to get into semiconductor manufacturing. You would have seen multiple fabs getting announced in Europe and in US. Some of them are up and running. Some of them are in the different stages of evolution, exactly like the fabs and OSATs and ATMBs of India. But I would say, looking at the demand that semiconductor market size by 2030 is estimated by multiple organizations to be somewhere close to $1 trillion. Now, from 600 billion in 2025 to go to trillion, that's a 400 billion growth, it's pretty big. It took 30 years to get to 600 billion, and then you are going to go in 5 years to a trillion. That means that much of fab capacity is required, that much of manpower is required, manufacturing manpower is required, and definitely a lot of capital investment will happen, which will enable the economic ecosystem of the countries which are taking the lead. So even in that respect, I would say India has done it brilliantly well, understanding the economic side of it. As I said, $100 billion in semiconductor, and then the value addition that happens, the other supporting ecosystems that come into play. So all the countries are realizing this, and that's why the policies of all the countries that you talked about are going through changes, because every one of them is understanding the economic impact. It's just not the system houses who will consume the chip, but then the backend ecosystem that gets developed and the numerous jobs, millions of jobs that it will develop. I think it's becoming very evident to policymakers.
Yeah, talking about US, the current policies on the immigration and the trade uh, tariffs, will these have any impact on the semiconductor operations in India currently?
I don't think so. I don't think so. And if the immigration related challenges continue, probably it will help India in a positive way, because then
Okay.
some of the talent that flows out will stay in the country, and it will augment the resource capabilities. And again, the second way I would look at it personally, I mean, it's not a official statement I'm making, but personally I would look at it that companies who have benefited from the strong Indian talent and what they have done would rather start more operations in India and grow them locally by using this surplus talent that they will have at their disposal. So in a way, it will in general terms, it will also normalize the cost of operations, which was otherwise threatening to spiral in the country. The cost of operations from the human resources point of view will normalize. More investments will come to the country. So I don't think it's going to affect negatively. And tariffs again, this tariff is not a permanent thing. So I think we are overreacting. Sometimes I get the feeling that we are overreacting to the tariff story, because that is cyclical and that is periodic, and it will keep going up and down. Today it is for a certain class of materials. Tomorrow it will be they become irrelevant, and then it goes into another class of products and materials. I mean, I remember maybe I just started my professional life. One of the item that attracted a lot of tariff was sugar. And today, nobody talks about sugar. And if you really look at the price of sugar in India, at least for the last 10 years, it has just remained flat. Right. So I don't think we need to worry too much about this the tariff related. I mean, it may be challenging for a short period of time, maybe a couple of years, but I don't think it will have a major long-term impact. I'm talking about the semiconductor domain and the electronics domain. I'm not talking about the commodities, but by and large, I don't think we need to worry about that.
So where do you see the India's?
We need not worry about that. I'm sorry.
Oh, well, that's great. Where do you see the India's growth in semiconductor area, like probably in the next 10 to 15 years, with all the encouragement given by the country through the India Semiconductor Mission and all that? So how do you see this domain going forward in the next decade?
Oh, this is going to be an absolutely super critical domain for the country. There's no doubt about it. As I said, I gave you the example of space. I gave you the example of atomic energy. Now, the green energy is becoming important and super critical. And semiconductors will remain one of those very, very important technologies that this country has to master and conquer. And if you ask me, let us put a timeline of 2035, 2037, 10 approximately 10, 11 years from now. I don't see any reason why India will not be the top five, or if not top three, definitely within the top five countries in the world. I would say designing, producing semiconductor products which the world wants. See, today, if you look at some of the startups, particularly these 20-odd startups that I talked about under the DLI, so where are they focusing? They are focusing on automotive electronics. They are focusing on green energy. They are focusing on telecom, 5G and beyond. So each one of these domains are going to be the torchbearers for the next decade. So if we can get, I would say, the 2025 becomes, let's say, 200 startups and driving different domains. Medical electronics is just waiting there for India to tap. So the future looks bright, and I'm sure, Sriganesh, both of us will see India becoming a top country in our lifetime when it comes to electronics and semiconductors. I have no doubt on that.
It's wonderful to hear that. What is the role of the critical minerals and the materials in the fabrication?
Oh, critical minerals, yes. So this is another little, I would say, less understood and a little touchy subject.
Mhm.
But there are. First of all, let me tell you, no country can manage the semiconductor ecosystem all by themselves, because there will be global dependency for, and if you need 150 different metals, minerals, components, what do you call gases, and all kinds of things, no country can be self-reliant in all of them. And to think that it will happen is probably not a wise thinking. So the dependency is going to be there, and the critical ones which are required in big volumes, and which are, I would say, practically the showstoppers kind of things. That's where every country will focus how they will become self-reliant. But where will the rest of the things will come from? So that's where partnerships, and including some of these FTAs and all that are happening right now, will all play into that aspect of the making the critical minerals and the materials available. So just to take an example, this Center for Strategic and International Studies in Australia, so they have identified a few critical minerals that are very, very important for the semiconductor manufacturing. I would say terbium, for example,
Okay.
or neodymium. These are very, very specific materials that are required, maybe very small quantities for months production, but they are without that you cannot do it. That kind of criticality. So like that, every country will have a small segment of or a piece of the pie, if I can use that word, in playing into the semiconductor manufacturing ecosystem. So identifying them, getting into the right partnerships with these countries where they are available is what I think the government is trying to do, so that we become self-reliant in semiconductor products, design and manufacturing, and the self-reliance also extends to sustainable partnership with countries who will provide us these critical minerals. But to answer your question in a nutshell, the availability of critical minerals and its role play in the semiconductor manufacturing ecosystem is very, very important.
Okay, so it is important for India to collaborate, with the countries which have these natural resources.
Yes, in fact, the collaboration works both ways. One, of course, getting these things that are required, the ecosystem components that are required for the manufacturing, and all the products that India will design and manufacture. Sriganesh, I have no doubt that they are all going to be consumed not only by India but by the world. Because I don't think if anyone, I'm pretty convinced that if anyone starts a startup thinking that, okay, I will develop a product and all of that I will be able to sell in India, I don't think he has understood the business well. So both as a supplier and as a consumer, there will be partnerships, country-specific partnerships, and global partnerships, and the global distribution networks. These are all the way this industry is going to evolve in the next 1 to 2 decades.
So how does the geopolitics influence India's strategy in this domain?
Well, at the moment, I would say geopolitically, India has a very good advantage because, see, at the end of the day, geopolitics also, in my opinion, I mean, I'm not an expert in geopolitics, but my limited understanding, let me tell you, if you are offering a solution to a global problem, then the countries who are serious about solving that problem will become your partner automatically. So geopolitics is where your strength of human resources, for example, and no, I'll amplify this point with one very specific example. India provided the manpower for software engineering for the world 20 years back, and it probably continues to do it to some extent. When the semiconductor manufacturing goes from $600 billion to $1 trillion, that's an increase of $400 billion. Think about and it's not just the manufacturing of semiconductor, the entire ecosystem that needs to support this huge increase in the demand of semiconductor products. India is sitting, I would say, on the cusp of another software like what I would say, becoming global supplier of well-trained manpower. I think India should not miss this opportunity, because it's not just the fabs in the country or the ATMPs in India will require these people. All these 30, 40 fabs and all the numerous OSATs and ATMPs that are coming up globally, they all will require very similarly qualified people. And with little focus, I'm not saying this in as a criticism, but VLSI design as a BTech subject started much later than when it should have been started, right?
Okay.
So semiconductor manufacturing, at least as an elective subject and the undergrad course in the BTech level, is absolutely must. And what does it require? Not only the curriculum and the teaching, but also requires small training fabs. And these training fabs are not very expensive. It can be set up. I mean, again, you don't have to do a 7 nanometer or a 5 nanometer fab for you to learn semiconductor manufacturing. But we can develop in this country maybe 5, 6 training fabs and train people with hands-on. And then there are some very good simulators, and India develops very good AR, VR kind of training tools. So a combination of all these four a good, well-structured curriculum taught by industry professionals with AR, VR augmented lab sessions, and then the actual lab sessions, and then simulation techniques. I think we can create world-class manufacturing talent. And semiconductor manufacturing is pretty complex. It requires truly multidisciplinary capabilities. And it has, you can think of every possible engineering stream when it comes to semiconductor manufacturing. And we have numerous colleges and we produce numerous engineers. So ISM 2.0, whenever it comes out, the Daylight 2.0, I'm hoping that it will also have a component of
Skill development.
skill development at a national level for the global requirement. So we will develop, manufacture, and sell semiconductor products. We will also develop semiconductor manpower for the world. I think we are getting into that journey very soon.
Wow, that's excellent to hear. Sometime earlier you mentioned about strategy for Australia. Any thoughts of how India could collaborate with countries like Australia to kind of be at least successful in the mission here?
Yeah, I can think of, though I must admit that, uh, I must admit that I'm not that familiar with the Australian ecosystem. But let me tell you something. There are two areas where a beginning can be made. One, of course, has already been made with the FTA that got signed between the two governments. So that was, I would say, a very good starting point. But then
Sure.
the Australian universities and the Indian universities can start collaborating in identifying some of the research problems that needs to be solved. If you want to become a major player in semiconductor design for the next decade, you need to have very, very good IP repository. And India is not that strong yet when it comes to semiconductor IPs. We are still dependent a lot on global companies. And I think we have to come out of that sooner than later. So collaborative pre-competitive research and collaborative IP development are some of the areas. And then, of course, the the critical metals, minerals is another area where very specific identification can happen and refinement processes can be started. And between Indian enterprises and the Australian companies, I think there could be a lot of exchange on this that can be formulated. I'm pretty sure it's only a matter of time before both the countries identify the mutual value and benefit.
All right. Yeah. So thanks for the time, and it's excellent to hear about the progress that India is making in this field, and I'm sure that India will have a very great future, in this domain going forward. And it's been excellent speaking to you. I thank you.
It's my pleasure. I'm delighted to have this conversation with you, Sriganesh. And I'm sure together we can try to work on some programs which will be of benefit to both Australia and India in the coming years.
Thank you.
Thank you. Thank you very much.